here to talk about this exciting new mission is NASA expert and astronomer Michelle Toller. Thank you for joining us. We appreciate it. So tell us about this new mission and how it's going to work.
Well, thanks, Britta. You were talking about some severe weather, but this is sort of the most violent weather that the universe possibly has out there. This is a telescope that launched early this morning from Cape Canaveral, Florida, and it's on its way off to actually look at the most extreme things in the cosmos, the areas right around black holes, exploding giant stars. And you mentioned neutron stars. Neutron stars are amazing. They form when a giant star collapses and dies, and so you get a ball that's about 20 miles across, but there's about 2 times the mass of the sun packed in there. So every little teaspoonful of that material would have more mass than Mount Everest. So talk about amazing things. This mission is actually keyed just to look at that.
So, Michelle, the IXPE is the first of its kind. So how does this differ than anything that we've done before?
That's right. Well, IXPE stands for the Imaging X-ray Polarimetry Explorer. And X-rays are a very energetic type of light. Most people know them from doctors' offices. They go right through you. You can see your bones and all of that. It's actually a type of light that's so energetic, most telescopes can't even catch it. It goes right on through. So this is a special telescope that actually catches X-rays. X-rays are blocked by our atmosphere. We're actually really lucky about that. Our atmosphere shields them from us coming in from space. So if you want to look at X-rays, you need to get up above the atmosphere. And we have sent X-ray telescopes into space before, but this one is special because it's looking at polarization, almost like polarized sunglasses. And what that allows you to see is actually where the magnetic fields are really intense, where the gas is millions of degrees, close to a black hole, close to an exploding star. This is our first detailed view of that.
And Michelle, with all this data that we're going to get from this awesome new Explorer, what are we hoping to do with that data to help us with life here on Earth?
Well, there's lots of reasons. We have to understand our environment, right? That's a big deal about knowing the weather around you, for example. Neutron stars are far away, sure. There was one that's about 50,000 light years away from us. A light year is about 6 trillion miles. But a couple years ago, there was a small quake on that neutron star, and it actually blew part of the top of our atmosphere off. It actually does affect our environment in space. We live in this larger galaxy. So we need to know about these things. We need to know how they work. But there's even a more basic idea. A lot of the atoms in my body right now, things like carbon and oxygen and all the stuff that makes up my bones like calcium, those atoms are only formed in exploding dying stars. So we are actually trying to understand how you get the chemistry, the conditions necessary for life, even here, even right inside you.
Interesting stuff. Now, Michelle, I know that NASA has another big mission that's coming up called the James Webb Space Telescope. So how is the IXPE going to complement that?
That's right. That's our big launch. It's coming up December 22nd, the James Webb Space Telescope, the follow-on to the Hubble Space Telescope. So James Webb looks entirely at the universe in infrared light. Infrared light is light that's actually too low energy for our eyes to see. It's a color that our eyes don't see that actually includes things like heat radiation, heat light. People have heard of infrared cameras, that kind of stuff. That's amazing because you can look at objects like, say, planets around other stars that are warm, but they're not glowing bright like a star. The other end of the spectrum is IXPE, the X-rays, light that's so energetic that we can't see it. That's the most violent stuff, the hottest stuff, the areas around spinning black holes, all of that. So in order to understand the universe, you need to see the universe in all the colors that it uses, a lot more than our eyes do.